The following is a video tutorial for how to create the Axel peg for the model miniature train. First, I'd like to take a look at the documentation provided by Project Lead the Way for us. And there's a bunch of different things that we need to take note of here. I'm just going to start at the bottom and work my way to the top. This first call out here says 45 degrees at a depth of 0.03. That is referring to the chamfer at the bottom of the part here. The next call out we see is this 1/4 20 UNC times by 1. That's referring to not only the threads here, but the length of the cylinder as a whole. So from the bottom of this head here, where the hex or the head of the peg here is, to the bottom of this is going to be 1 inch. And then the bottom of this says 1/4 of an inch offset, meaning that this portion here has an offset and does not have threads. So I'll show you how to enter that in Inventor when we get to that, and it's actually a little tricky. So this is one of the most difficult things with making this part. Some of the other things we should take note of here is this diameter of 0.422 for the outer edge, a radius here of 0.236, which is referring to this curved portion here. And then we have a hex socket head, which is referring to this hole here, which is a hex, a polygon with 6 sides. And it has a distance across the flats, so a distance between parallel flats is 5/32 of an inch. And then of course here it goes in 0.111 inches deep. Some of the last things to look at here, this part will actually have a flat top to it, when that is going to have a diameter of 0.25. And then the last two things here is telling me the thickness of this lip right here is 0.031. And then the overall thickness from the start of this head here to the top is going to be 0.125. So that's their documentation. They provided it for us in an isometric view. If you take a look at my documentation here, I provided it in a top view and a front view. And basically we have all the same numbers. One of the things that you see here a little bit clearer, I feel like, is this chamfer at 45 degrees with a depth in of 0.03. So it's a little bit easier to see that in this front view than it was in this isometric view here. Alright, now I'd like to jump over to Inventor, and actually I have this part created already. So I just wanted to take you through all the commands here that we're going to do, and then I'll go ahead and start a new file and take you through that step by step. But just want to double click here on my original sketch, and you can see that this profile and how the dimensions are laid out here. This arc here is actually going to be a little bit different than how when we made the parts for the hitch peg and the linkage peg. You remember we had to actually make a circle and then dimension it into place. Well, for this, since there's these flat edges on the top and on the side here, we won't be able to do that, and so we can actually just get away with making an arc between the two endpoints and then dimensioning it to 0.236. Alright, so I'm going to click on Finish Sketch. Then of course we revolve it around itself 360 degrees. Then the thread here, you can see this is where we add in our offset information, the length here, and then we can check and make sure that the specification for the threads is correct. The next thing that I did was I sketched out the polygon on the flat surface at the top. Set my distance between flats and making sure that it was centered appropriately. Finished that sketch, and then I extruded it through at a depth of 0.111. And then lastly was the chamfer on the bottom of the part. This chamfer is actually made using that second option, the same thing that we had used to make the smokestack chamfer. It's a distance and an angle, and that is the information that they provided for us. The distance is 0.03, the angle being 45 degrees. Okay. So now that I've walked you through one of these completed parts already, let's go ahead and make our own together. I'm going to go ahead and select on New Part, making sure that we're on English, Standard Inch IPT, Create. The first thing I'm going to do here is go ahead and create a sketch on this plane, and I'm going to lay out my profile. Jumping back over to my documentation here, I can see that the overall height is going to be 1.125. So in Inventor, that's the first line that I'm going to throw down here from the start point, going straight up at 1.125. Hit Enter. Next, I can jump back down to the bottom here. I know that the diameter for this is going to be 1/4 of an inch, so 0.25. And since I'm only doing half of the part right here, I could do 0.25 divided by 2, which of course is 0.125. And you see Inventor does the math for us there, and they lay down that 0.125. Next, I'm going to do my line that goes up 1 inch. So that'll be the next thing here. I'm going to select my line and go straight up at 1 inch and hit enter. Alright, now I need to know how far out this flat is coming on the top here and how far out this part goes here, and then that extra flat piece going up. So let's look at our documentation and see if we can figure that out. I think it might be more helpful at this stage to look at the numbers that are provided in the Project Lead the Way documentation. It says here that that diameter for that outer rim is supposed to be 0.422. So use in Inventor here. What I'm going to do is I'm going to select my line tool. If you see, if I come off of this corner here, you should see a little dashed line. It's actually kind of helping you relate where your next line is going to start to the end of that line they already have in there. So I'm actually going to take this back over to this line to where it intersects and click once, and now I have a line, and I'm going to bring it out in the right direction. And the diameter was originally 0.422, so I'm just going to enter that and say divided by 2, and that is our distance, in which is this is going to come out. I could trim this piece off here just to clean it up a little bit. Might need to delete that dimension just to get it out of the way, and I can come in here and say I don't need you anymore, see ya. The next thing here, looking at their documentation, I need that flat piece on top. And that's actually going to be this diameter that we see, 0.25. So again, I'm going to come back over here, starting at the top, bring out a line to the right, type in 0.25 divided by 2, and just like how we did at the bottom, it's going to be 0.125 then. And then lastly, I need to know how high this line is coming up here, and then I can connect the 2 points here with an arc. And our documentation says the thickness of that is 0.031. That's what I'm going to put in, make a line here, select the point, go straight up at 0.031 and hit enter. Lastly is going to be our arc here, so I'm just going to select arc, select a first point and an end point. Here's my arc, and at this stage, before I click anything else, I'm just going to enter in what I needed that radius to be. And if I just jump over here real quick, I can double check that. And it needs to be 0.236. So 0.236, enter, and there we have it. Alright, so that is the profile, the way that it is laid out and it needs to be. I'm going to then say finish sketch. Okay, and of course now we can revolve it around itself. So I'll say OK. Alright, and then the last 3 things I need to do is add that hex hole at the top, put the threads on, and then chamfer the bottom. So I'm going to do the hex hole next. I'm going to say create a sketch, and I'm going to select this flat surface at the top here. It's going to take us into a top view. I'm just going to zoom in a little bit, and one of the first things I'm going to do is lay out a straight line from the center point all the way out to here somewhere. It doesn't matter how long it is, but I want to use this line to help square up and make parallel this polygon in a second. So once I have that line down here, I can then come over to my polygon tool, and I need 6 sides, and that's the default setting, so I'll leave it as so. And then I'm going to make sure that I'm going to do an inscribed polygon, and that'll allow me to select the center point here and simply drag out and place this polygon in here. Now, it's really difficult to get this to look flat inside the view, and I want it to look flat in the view so that when I put together a top view or something like this, it'll look neat and clean. You won't have a slanted polygon in there. I just think it makes it look a little bit more professional. So what I'm going to do is I'm going to click and have it be a little off tilt so it's not flat, so a little bit off tilt. And I'm just going to say done for my polygon tool and hit escape to get off of that. And now I'm going to come up here to my geometric constraints. And I can use this parallel constraint that I see here to select the top of the line here and this line there, and you'll see it'll actually kind of pump it over into space, push it over so that it's nice and flat, and it's parallel, or it will be parallel when I look at it from a top view in the future. I no longer need this line here now, so I'm just going to right click and say delete for that. The last thing I need to do though is dimension between flats. So I'm going to select dimension there and select my two lines. I'll place that dimension and then just jump back over to my documentation here, jogging my memory that it needs to be 5/32 of an inch across the flats and at a depth of 0.111. Okay, so this needs to be 5/32. So I'll type in 5 divided by 32 and hit enter. Now I'm finished with that profile. It's centered on there, so I can say finish sketch. And then next I'm just going to extrude cut that profile into the part a little bit. So I'm going to come over here, making sure that I select my cut extrude option. And then I will select that polygon. And for the depth, for the distance, I'm going to cut it out as 0.111. Now I can say OK. And that added that feature right to the top. Last two things, add a thread and then chamfer the bottom. I'm going to do thread first. And this is actually a little bit difficult. It really depends on what you click first before you click anything else, and it matters in sequence what's going on here. So let's just take a look at that thread callout that I looked at earlier. It's a 1/4 20 UNC. It is 1 inch long from there all the way to the top, and it has a 1/4 of an inch offset from the top here. So if I jump over to the specification tab, actually I probably need to place it first because there is no information in there. So the first thing I'm going to do is I'm going to deselect full length before I select a face. I'm going to deselect full length. I'm going to enter in the fact that I need a 0.25 offset and that the overall length needs to be 1. And at this point I'm going to select the face option here, and then I'm going to come over to my part and watch what happens. Depending on where you have your cursor, you can actually tell it to have that offset either on the bottom or the top of this peg. Of course, we want it on the top, but if you accidentally click on the bottom, it will put it there. So you need to make sure that we're clicking at the top here, and we say OK. Now I can jump over to the specification tab and make sure all this information is correct. 0.25 for size and a 1/4-20 UNC for designation is correct. I'm going to leave it at right-handed, that is fine, and I'll say OK. Great, so now we have our thread added onto the part, and the last thing here is going to be our chamfer. So I'm going to select that option. I'm going to select this second option here for chamfer, distance and an angle. That's the kind of information that's been provided to me, so that's the one that I want to do. And it's a 45 degrees at 0.03 inch distance. So for distance here, I'm just going to type in 0.03. And the angle, of course, was 45 degrees, so I can leave that as so. And then I need to select two things, a face and an edge. I'm going to zoom into the bottom here so I can see this just a little bit better. The face is actually going to be the cylindrical outside of the cylindrical part, so I'm going to select that first. And the edge will be this ring down here. Make sure that you just grab that white ring when you hover over it. You can see there, you can visually check to make sure that that is what you want. This is what we want. So I'll say OK, and that is it. So this is how you create the part. You have to create a sketch, revolve it, another sketch at the top for the hex and cut it out, add your thread, add your chamfer, and you're done. Of course, the last thing I need to do is set my ABS plastic, and then I can go and take a look at my eye properties menu here. I'll update my fields, and it says I have a mass of 0.002, an area of 1.2, and a volume of 0.06. So now that I have those figures, I'm just going to go ahead and double check that to make sure that that was what we wanted. I'm going to scroll down here to the hex peg, zoom in a little bit on that area, and you can see that's exactly what we wanted. 0.002, 1.2 for an area, and a volume of 0.06. So those numbers match up very well. And that is how you create the part. And that is all.